Hello everyone. Now we'll see how to separate positive and negative numbers in a given array which is stored in the external RAM memory of 8051 microcontroller. So here we have to write assembly language program to separate positive and negative numbers. First let us define the array size, let it be 10. So 10 numbers or 10 bytes are stored in the external memory. Now let us consider starting address of that external memory as 1000H. So from 1000H up to 1009H, in this memory location 10 bytes or 10 numbers are stored. Once these numbers are stored and array is formed, we have to identify positive and negative numbers. Move all the positive numbers to the internal RAM. Now suppose 20H is the starting address where positive numbers are stored. Similarly, move all the negative numbers to the internal RAM and consider starting address as 30H where negative numbers are stored. Now to write the program, assembly language program, and to execute that I am using Keil Microvision tool. So open that Keil tool, go to project and select new project. Here I am giving that project name as P1. Save the project and next select the target device. So it is Atmel89C51. Okay. So now project is successfully created. So once project is created, in the next step I have to create a new text file and here program is typed. So program is written in the text file. Next save this file with the extension .asm. So p1.asm, this is my file name. So file is saved. Now in this program we are using RLC, that is rotate left through carry instruction, to check whether the number in the array is positive or negative. So as we know, in 8051 the most significant bit or MSB of an 8-bit number indicates its sign. If that MSB is 0, number is positive. If MSB is 1, number is negative. Therefore, first we have to move content from the array or numbers from that array into the accumulator. Then use the RLC A instruction. So by rotating that accumulator left, the MSB moves into the carry flag. Then in the next step, we can use jump if carry or JC mnemonic to check whether content of that carry flag is negative, that means content is 1 or 0. If carry equal to 1, then number will be negative. If carry is equal to 0, then number will be positive. So like this we can check each number and then we can move it to appropriate location of the internal RAM. Now if we check this program here, in the first line we have org000H. So this defines the starting address where your program is stored. So assembler directive org is used here. So origin is defined as 00H. So program is stored starting with that address. Next we are using DPTR here because our array is stored in the external RAM memory location. So starting address 1000H is stored in the DPTR. Next we are storing positive numbers with starting address 20H and negative numbers in the RAM location with starting address 30H. So R0 and R1 are used to hold positive number address and addresses of memory location where negative numbers are stored. Next array size, that is 10 or 0AH, it is stored in R2. So move R2 #0AH is used for this purpose. Next, to check whether number is positive or negative, we have to move content from external RAM memory to the accumulator. So use the instruction move x a at DPTR. So with this instruction, first number which is stored at 1000H is moved to the accumulator. Now let us temporarily store this accumulator content in the register B. So use move b, a instruction. Next, this is the main part here, RLCA. So content of that accumulator is moved left through the carry. Now if MSB is 1, then obviously that number will be negative. So we have to check that. So for that we are using the instruction JC negative. So if any carry is generated, that means if carry equal to if that carry equal to 1, then jump to the label negative. Now what we have to do? Number is negative, so we have to move that number to the 30H memory location. So this 30H, it is pointed by register R1, so use the instruction move at R1 comma B. So in B we have the number, that number is moved to the memory location 30H, and then increment R1, because the next negative number, it is stored at 31H. Therefore, for that purpose we are incrementing R1. Next, once first number is stored, then we have to increment the DPTR. Now DPTR is directed to 1001H, and then already first number is moved, therefore we have to decrement that R2 by 1. Initially it was 10, now it is decremented to 9. So 9 is not equal to 0, it is greater than 0, therefore again jump to the label up. So again second number is copied to the accumulator, and that second number, it is temporarily stored in the register B. Again RLC A instruction is executed here. Now again content of that accumulator, it is moved through the carry. If carry is generated, then it will be negative number, otherwise positive. Now suppose in this case, the second case, carry is not generated. In that case definitely it is a positive number. So we have to move that positive number to the 20H memory location. So we have that instruction here, move at R0 comma B. So R0 is pointing to 20H, so the content of B is moved to the 20H memory location. Now if the next number is positive, then we have to store it in the 21H memory location. So increment R0, so now R0 is incremented to 21H. Next jump to the last. So it is an unconditional jump, so last is the label, now it comes here. Next increment the DPTR, so now DPTR is incremented to 1002H. Next decrement R2 value, already it was decremented to 9, now again it is decremented by 1, so 9 to 8, again jump to up. So this process is repeated 8 more times. Once all that 10 numbers are checked for its sign and move to the respective internal memory location based on the sign, then we have to terminate the program. So this is the end of the program here. So this is the logic. So our program is ready now. Add files to the source group, change the file type, select the program and add it to the source group. Next build the target. Now there are no errors, so we can move to the next step, start the debug session. Okay. Now access the external memory through the window 1. So external memory x colon 0x1000h. H is not required here because we are using 0x here. Okay. So give 10 bytes of data. So suppose first data is D3 here, second data C8, next 22, next value F7, this is F7, next value suppose it is 2D, next 17, next value 4C, next 5C, next A6 and 10th number, last number, it is A7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 different numbers are given here. This is 1000H. external memory location, and this is 1009H. Next, use second memory window here, D colon 0x20. So this is 20 here. Next, use third window. Here you define 0x30. So memory window 3. Here we can check the negative numbers. Memory window 2. Here we can check the positive numbers. And memory window 1. Here we have given array stored in the 1000H memory location. Next, let us execute this, run the program. So program is successfully executed. Check the memory window 2. Here 22, 2D, 17, 4C, 5C. So these 5 numbers are the positive numbers, because this 22, this can be represented as 0010, 0010. So it is 22, most significant bit is 0. Next we have 2D here. So in this 2D, first bit it is 0. So 0010, it is 2. Then D is 1101. So it is a positive number. Similarly, we can check the remaining numbers here for the sign. So it is positive number. Next, in the memory window 3, we have D3 as the first entry. So D3, so 1101, 0011 in binary. So most significant bit is 1 here. Similarly, here we have C8. So C starts with 1, again it is negative number. F7, again it is negative. A6 and A7. So there are 5 negative numbers stored at 30H memory location. So 30, 31, 32, 33, 34. So in this memory location we have negative numbers 20, 21, 22, 23, 24. In this memory location we have positive numbers. So this is how we can separate positive and negative numbers in any given array. Thank you.